Hello everyone! My name is Wani
My name is Anna.
My name is Ina. And I am Natasha.
and we will explain about process in operating system. What is process? Process is an instance of a computer program in execution. Each process has its own private resources, data and associated statistics. Next, we move to process concept. In process concept, operating system will calculate how much program have to run in CPU. The second one is operating system will execute a variety of a program, which is batch system or known as jobs and time shared system or known as user program or task. Process includes a program counter, stack and data section. Next, we move to process in memory. This is one of diagram process in memory. First is stack. Stack contains temporary data. The second part is we call as space. This space we call as dynamic part. The third one is heap. Heap contains memory dynamically allocated during runtime. The fourth one is data. Data contains global variable that has been requested by user. And the last one is text. Next, we move to process state. In process state, we have 5 states. The first one is new, the second one is ready, the third one is running state, the fourth one is waiting state, and the last one is terminated state. In new state, the new state is being created after the user requested a job or program that needs to be executed. Then, after that, the process is admitted to ready state. In ready state, the process is waiting to be assigned to a processor using a job scheduler. Then it comes to running state. In running state, the instructions are being executed. The state have to save some particular jobs. If program need input or output, it will go to waiting state. Waiting states as other job also have to be run at the same time. After the waiting job is over, then it will come against the ready state. After the job is completed, the process will terminated or finish execution.
I will explain about process control blocks (PCB).
Control block PCB. Each process is represented in the operating system by a process control block PCB, also called a task control block. PCB is the data structure used by the operating system. Operating system groups all information that needs about particular process. This is the diagram of process control block PCB. In the stage 1, process state. Process state is maybe new, ready, running, waiting and so on. Process number, the second one, which is depend on turns. And the third, program counter. Program counter is depend on what particular stage execute. The fourth, register. Register include general purpose register, stack pointers, index registers, and accumulators. Example, the number of register and the type of register totally depends upon the computer architecture. The fifth is memory limits. Memory limit is to prevent program running from crashing. The sixth, list of the open files. And the last one is this. Scheduler. We have two terms in scheduler. The first one, long-term scheduler, or we call job scheduler. It selects which process should be brought into the ready queue. The second one, short-term scheduler, or we call CPU scheduler. It selects which process should be executed next and allocates CPU. Sometimes the only scheduler in a system. And now we go to scheduler content. The first point in scheduler content is short-term scheduler is invoked very frequently. We use millisecond to measure it, and it must be fast. The second one, long-term scheduler, is invoked very infrequently. We use second or minutes to measure it, and it may be slow. Third, the long-term scheduler controls the degree of multiprogramming. Next, process can be described as either first, input-output bounce process. It spends more time doing input-output Then computation, many short CPU bursts. The second one, CPU bound process. It spends more time doing computations, few very long CPU bursts.
Next, I will explain about process creation and interprocess communication.
Process creation. Process creation is a process which creates parent process to children process. It managed via process identifier, which is PID. We have in PID process ID or PID. It is an active process Unix Mac OS X or another operating system. In process creation, we have two, which is resource sharing and execution. Resource sharing, parent and children share all resources, while children share subset of parent resources, and parent and child share no resources. Execution, which is parent and children execute concurrently. Parents wait until children terminate. Process creation's content have address space and Unix examples. Address space child duplicate of parents while child has a program loaded into it. Unix example, fork system and exec systems. So this is the diagram of process creation. We have fork, exec, exit. While fork to parents will fork, waits and resumes. This is another kind of process termination also. Interprocess communication. It is a process in system may be independent or cooperating. For example, if there is two people and they were not communicating, it will become independent communicating. But if they have some kind of communication, we call it cooperating. Okay, there are many reasons of cooperating process. First is information sharing. Next, computation speed up, modularity and convenience. In interprocess communication, which is IPC, we share memory and message passing. Message passing is when two people interact each other. They will send and some of the people will receive it. Independent. Independent cannot be affected by execution, another process. Cooperating also can affect by execution, another process. Properties communication link. We have two, which is direct and indirect. Direct, established automatically, while indirect only if process share a common mailbox. Link may be unidirectional but usually directional for direct, but indirect may be directional or bidirectional. Indirect also associate with exactly one pair of communicating process, but indirect associate with many processes.
I will explain about synchronization, buffering, and local procedure calls.
Next is synchronization. Message passing may be either blocking or non-blocking. Blocking is considered as synchronous. Under blocking, there is 2 points, which is blocking send and blocking receive. Blocking send has the sender block until the message is received. Meanwhile, blocking receive has the receiver block until a message is available. Next is non-blocking. Non-blocking is considered as asynchronous. There is 2 points under non-blocking, which is non-blocking send and non-blocking receive. Non-blocking send has the sender send the message and continue. Meanwhile, the non-blocking receive has the receiver receive valid message or now. Buffering means queue of messages attached to the link, which is implemented in one of 3 ways. First, zero capacity, which is 0 messages. Zero capacity means sender must wait for receivers. Second, bounded capacity, which is finite length of n messages. Bounded capacity means sender must wait if link full. And lastly, unbounded capacity, which is mean infinite length. Unbounded capacity means sender never waits. First thing first, a server process first creates a named server connection port object and waits for clients to connect. Second, a client requests a connection to that name port by sending a connect messages. Third, if the server accepts the connection, 2 unnamed ports are created. First, client communication port.
which is used by client threads to communicate with a particular server. Second, server communication port used by the server to communicate with a particular client. One such port per client is created. And fourth, and the last one, the client receive a handle to the client communication port, and server receives a handle to server communication port, and the inter-process communication channel is established.